Hi, Math 30-1s. This lesson is going to be lesson 3 in your student workbook, which corresponds to page 303. It's on something called synthetic division. In lesson 2, I introduced long division to you. This is another alternate way to divide polynomials. You will find that this is a much more efficient method of division than long division because it doesn't contend with all the variables that long division does. Once you get your head wrapped around synthetic division, if I ever gave you the choice, 99% of you will divide using synthetic division. So what we're going to do is nothing is on page 303 of your workbook, so you could actually flip, and the first class example is on page 304. Okay, how do we do synthetic division? How do we set this up? So the first thing is you're always going to be given a division statement. So they're giving us this polynomial here, and they're saying, please divide it by this binomial. And remember that whatever you divide a polynomial by, that's going to be called the divisor. So that's our divisor. And this here, that's our p of x. I'll erase that in a bit so that we have a bit more room. So if I was to write this as a division statement, it would be 2x cubed minus 3x squared minus 8x plus 15. And that polynomial, so that is our p of x, it's being divided by the divisor of x minus 1. Okay, how we set up synthetic division is we use what's called an upside down division bar. So this bar right here represents, it's what we call our upside down division bar. And then what you put in your upside down division bar is these numbers correspond to the coefficients in your polynomial. So before we put the numbers down, we have to make sure a couple of things. We have to make sure a polynomial is in descending order of x, and then we have to make sure we're using 0 as a placeholder if needed. So if I look at this polynomial, 2x cubed minus 3x squared minus 8x to the 1 plus 15, which is my constant, it is in descending order of x, and I don't need to add any placeholders. So I'm ready to start setting everything up. So I take the 2 in front of the x cubed, and I write it down there. Take the negative 3, and it's written there. The negative 8 is written for us, and then the 15. Then you say to yourself, okay, how do I figure out what goes in front of this division bar, this upside down division bar? And what that corresponds to, the number you put in here, it corresponds to the root of your divisor. So this is our divisor. And if I said, okay, well, what's the root of that divisor? You're going to take what that divisor is, and you're going to set it equal to 0. The root is equal to 1. So whatever the root of the divisor is, it goes in front of the division bar. All right. What you then do is with synthetic division, you move the first term down, which is a 2, and we're going to perform a multiplication. So we're going to say 2 times 1. Okay, 2 times 1 is 2, and that gets written here. Then with long division, we subtracted. With synthetic division, you add. So negative 3 plus 2 is going to give you negative 1. Then again, you take this number and you multiply it by that number. Negative 1 times 1 is negative 1. And that's going to go here. And then you add. Negative 8 and negative 1 is negative 9. And lastly, we're going to say, okay, negative 9 times 1, what does that give you? That gives you negative 9. So where does that go? That goes right here. And then we add. 15 plus negative 9 is 6. What do these numbers represent? So it's really interesting. This last number, you're always going to circle or you're going to box this in. That's always going to be your remainder, okay? These numbers here, so all of the numbers in front of the last number, these are going to represent the coefficients of your quotient. And I'm going to just call my quotient Q of x, okay? So if I was to figure out, well, how do I write Q of x? Like, what is Q of x? So Q of x, my quotient, here's how we do this. my original polynomial, you have to look at what degree it was. This original polynomial was a third degree polynomial. So my quotient, it is always going to be, the degree of the quotient is always one less than the degree of your original. So if this was a third degree polynomial, this quotient is going to be a second degree polynomial. So this 2, because it's going to be a second degree polynomial, it'll be an x squared, and then minus 1x minus 9. That's my quotient, okay? If I was to go from here and set up my answer, so we're going to rewrite my polynomial. So remember that your polynomial is your divisor, which is d, times your quotient plus your remainder. How I would write that is p of x. So this original polynomial, how they get that, it's equal to my divisor, which is x minus 1, times my quotient, and this is my quotient here, so 2x squared minus 1x minus 9, plus the remainder, and the remainder was 6, so plus 6, okay? And I will box that in. That is the answer for class example number 1. Let's look at class example number 2. So this is just going to be practice with synthetic division. So first thing, set up your upside down division bar. So make sure that's set up. Then let's look at our polynomial. So consider this polynomial here. This is going to be our p of x. Let's make sure it's in descending order of x, and let's check, do we need any zeros as our placeholders? So x to the 5, x to the 4, there is no x to the 3, x to the 2, x to the 1, and our constant. So what that means is I do need a 0 as a placeholder. So my polynomial written with the 0 as the placeholder is going to be 5x to the 5 minus 6x to the 4 plus 0x to the 3 plus 3x squared minus 2x plus 1. Okay, that is my polynomial function written in ascending order of x, and I have a 0 as a placeholder in there. So now let's set up our numbers within our upside down division bar. So what I need is I need the coefficients in front of all of my variables. So 5, negative 6, 0, 3, negative 2, and 1. Okay. Let's set up the number in front of our division bar. So remember that number, it always corresponds to the root of your divisor. So this is my divisor here. So to find the root of it, x plus 2, you set it equal to 0, and that root is negative 2. Okay, finishing off with the synthetic division, you drop that 5, you always drop that first coefficient, and then you perform a multiplication. 5 times negative 2 is negative 10. In synthetic division, we always add. So we'd get negative 16 here. Negative 16 times negative 2 is positive 32, and when we add, we get 32. 32 times negative 2 is negative 64. Okay, now you're going to add, right? So 3 plus negative 64, that gives you negative 61. Negative 61, so remember it's always that number times this number. So negative 61 times negative 2 is going to give you a positive number, and that will be 122. Negative 2 plus 122, that gives us 120. 120 times negative 2 gives me negative 240. And then when I add 1 plus negative 240, I get negative 239. Okay, I always circle this. That last number is always my remainder. This is always going to be my q of x. When I write down my q of x, what my quotient is, right? Your quotient is q of x. I look at the degree of my polynomial function, and it was a 5th degree polynomial. So the degree of my quotient is going to be 1 less. This is going to be a 4th degree polynomial. So my quotient is going to be 5x to the 4 minus 16. So these, remember, are your coefficients. Minus 16x to the 3 plus 32x squared minus 61x, and then there's my constant, plus 120. So that's what my quotient is. And what this question actually says is use synthetic division to find the quotient and the remainder. So if I needed to box that in, that's my quotient there. Or sorry, that's my remainder. And this is my quotient. Okay. Okay, what we're going to do now is it says find the value of the polynomial when x is replaced by -2. So this is my polynomial up here. That's my p of x. Right? That function is my polynomial. That's p of x. So what I'll do for b is I'm going to write p of x is equal to, so let's write out that polynomial. 5x to the 5 minus 6x to the 4 plus 3x to the plus 3x squared minus 2x plus 1. So what they're saying is they're saying what's the value of this polynomial when x is replaced with -2. So here you have an x, so take out that x and put in a -2. Therefore, within the polynomial, every single time you see an x, take out that x and put in a -2. So that would be 5, -2 to the power of 5 minus 60, or this should be 16. Okay, minus 16, -2 to the 4. Just looking at something really quickly. Okay, plus 3, -2 squared minus 2 times -2 plus 1. From here, p of -2, let's evaluate all of our exponents now. So what I would have there is 5 times -32 minus 16. -2 to the 4 gives you 16. Plus 3, -2 squared gives you 4. Plus 4, because negative and a negative give you a positive, plus 1. From here, you could punch that into your calculator. So -2 is equal to, you should get -160 minus 96 plus 12 plus 4 plus 1. And p of -2 is equal to -239. Okay, so what I want you to see from question B is that when I substitute -2 in for x, right, and remember that -2 was the root of our divisor, what I get if I substitute it into the polynomial is I get this remainder of -239. So the remainder, when dividing by x plus 2, so the remainder, when I divide by x plus 2, it's going to be the exact same value as when I replace x in my polynomial by -2. Okay, so actually what I think I want you to do is let's write that down for C. So C, I don't have it, but it says comment on your answers in A and B. So what I want you to write is the remainder when dividing by x plus 2 is the same as the value of the polynomial of when x is replaced by -2. Okay, so again, what this is just saying, to summarize what I just wrote here, when you take a polynomial and you divide it by this divisor, we get a remainder of -239. You're going to get that exact same number when you take that polynomial and you substitute x with -2, right? When you substitute in the root of the divisor into the polynomial, you are going to get the remainder. So this number right here, that is our remainder. Let's flip now to class example 3. So this is at the bottom of your page. Okay, so class example 3. If x plus 3 is the divisor in the following synthetic division, calculate the values of, we'll calculate our missing values here. Okay, so x plus 3 is the divisor. If we're finding the root of this divisor, x plus 3 is equal to 0. The root is -3. That goes in front of our division bar. They drop down that 2, which is correct, and then we need to perform a multiplication. So 2 times -3 is -6. When we add these two together, you're going to get -4. -4 times -3 is 12. Now you know that we need to add those two to get this answer. So let's write that off to the side. -m plus 12 is equal to 2m. So let's solve for m. Let's add m to both sides, and then I'll get 12 is equal to 3m. And from here, if I divide both sides by 3, I get m is equal to 4. So I just figured out what my m value is. So they want the values of m and p. M is equal to 4. So now what I'm going to do, if m is 4, this number here is 2 times 4, which is 8. So I'm just going to cross this out, and I know that that's 8. Okay, to get the value of n, we know that it's 8 times -3. So 8 times -3 is -24. Okay, so 8 times -3 is -24. And then I need to add this to get p. So let's see what we get. 16 plus -24 is equal to p. And p would be equal to, this becomes 16 minus 24 is equal to p. P is equal to 8. Okay, and if p is equal to 8, and I say, -8. If p is equal to -8, remember that this right here, that is our remainder. Okay, we're going to do one last class example, which is class example 4. And then it's a very similar method to this, and then I'll give you your homework questions. Okay, so class example number 4. When this polynomial is divided by this divisor here, it gives us the remainder, and it says that the remainder is 3. Okay, determine the value of a. So let's make sure this polynomial is in descending order of x. So x cubed, x squared, x to the 1, and then our constant, so that's fine. That's our divisor, so my root is going to be -2. So the -2 goes there. And let's fill this in. 2, -4, an a value, and 3. Okay. And then eventually I'm going to have to do something with that remainder. Okay, so let's figure out the synthetic division. So bring down that 2. 2 times -2 is -4. -4 plus -4 is -8. -8 times -2 is 16. A plus 16 is going to be a plus 16. And then remember, it's this times -2. So if I do that off to the side, it's negative 2 times a plus 16. That's going to give me negative 2a minus 32. Okay, then how you get the remainder here. Now we do know that the remainder is 3, but how you get that remainder is this plus this, right? So let's figure out what this plus this is, because how we get the remainder is we add these two. So let's do that off to the side. 3 plus negative 2a minus 32. Okay, and we know that this is going to be equal to, so this plus this equals our remainder, and they say the remainder is 3. So we're going to know that that's equal to 3, because what this question is asking is determine the value of a. So this is 3 minus 2a minus 32 is equal to 3. And then let's combine our like terms. So 3 and minus 32, that's going to be negative 2a minus 29 is equal to 3. Add that negative 29 to both sides. Negative 2a is equal to 32. Divide both sides by negative 2, and you get a is equal to negative 16. That concludes this lesson. Your homework questions that I would like you to do. So the homework questions on page 306, numbers 1, number 2, B and D. I want you to do number 4, 5, 6, number 10, and number 11.